Number 18, arrange the following pairs from strongest to weakest attraction. So A, we have a polar molecule and a polar molecule. B, we have a nonpolar molecule and a nonpolar molecule. C, we have a polar molecule and an ion. And then we have an ion and an ion. Now, this is a very important idea. Remember, when we have polar molecules, we have partial negative charges and partial positive charges. And from those partial charges, we get electrostatic attraction. Those are partial charges, meaning they're less than 1. They're not a whole charge. But when we talk about an ion, we're talking about at least one whole charge. It's going to be a +1. It can be a +2. It can be a +3. It can even be a +4. Or -1, -2, -3, or -4. Right? We can have these large charges, these humongous charges that are way more than a partial charge, because a partial charge is less than 1. And so what we need to understand here is anything involving an ion is going to be stronger in its electrostatic attraction than something that is simply partial charge. So when I look at D and I see an ion to ion attraction, that's a whole charge with a whole charge. So that's going to be the strongest thing on this list. Then I look at C, and I see something with a whole charge, and then something with a partial charge. Okay, it's not as strong as D, but we still have that ion in there in C, so it's still going to have a whole charge involved, so that's going to be pretty strong. So second I'll put C. Then I look at A, I have polar molecule and polar molecule. So those are going to be two partial charges. And so we've taken a step down from a whole charge being involved, and they're both partial charges. And B is going to be my weakest attraction because it's going to be nonpolar and nonpolar. So there's no dipoles here. Okay? There's no partial positive end. There's no partial negative end that sticks around for any length of time. The only thing that we're going to experience in a nonpolar molecule and a nonpolar molecule is going to be some instantaneous dipoles, some Lund dispersion forces, in other words. And those are going to be fairly weak in general. So our correct sequence is going to be D, C, A, then B.